So the median is a great statistic for central location. In fact, it is actually defined as the central data point. So it is the middle value. So let's say that I've got my income distribution again, and I've got some families making 60,000, some families making 80,000, some families making whoa, what? 200,000. Now I know that the average is going to be pulled way up by this number. In fact, let's make it even more dramatic. So $60. Somebody gives you $60 or $80 or 200,000. I mean, wow, like that's a big difference. The median is simply the central number. Like if we had ordered all of our numbers like they are here, the median just reports the central number. We actually use median when we're reporting U.S. household income. So in almost any news story, when you hear a report about U.S. household income, it's usually the median that they're reporting. Like the journalists are hip to the misleading nature of the average, and so they'll report the median. They'll basically say, you know, let's list out every single family in the U.S., including Jeff Bezos's, you know, billions and billions, and then, you know, like homeless people who have no income at all, some folks who owe money and have a little bit of negative income. List them all up and then take the central value. That's, I think, a very intuitive number, and it's useful when you're calculating statistics to report both the mean and the median. If they are very similar, great. Probably means you have a nice and symmetric distribution, which you should double check, of course, by graphing. If there's a big difference between the mean and the median, then you really need to start thinking seriously about which is the more accurate measure of income for most people, or the best description of your data set. The median is awesome because it's robust to outliers. And if I were to add a few more zeros here to these three numbers, the middle number is still 80. It didn't change. So we say that the median is robust to the presence of outliers because it didn't change at all, even when we added, tons and tons of zeros. Whereas the average really does depend on what happens with those high numbers. They pull up the average a whole lot. Now some students wonder what will happen if I have an even number of values. Because here I had 3. And so it was very clear what the middle one was. Or if I had 5 numbers, well, I got 2 below, 2 above, and that's my middle number. So it's a very well-defined thing. Right, so here's my example for an odd. But what if I have an even number, like 1, 2, 3, 4? Well, then I don't have specifically a middle number. And most of the time it really doesn't matter. Usually you have a whole lot more than 4 numbers, and so the difference between 2 numbers isn't going to be much. But still, you got to calculate something, and what almost everybody does if they have an even number of observations, they just take the 2 numbers that are closest to the middle, and they just report the simple average of those 2 numbers. And so your median in this case would be 2.5, just the average. Add 2 plus 3, it's 5, divide by 2, that's 2.5. Okay, so we like the median. Speaking of the difference between mean and median, what we're looking at here is data from the Federal Reserve Economic Database on U.S. household income, specifically comparing average income, the mean, and median income, this red line, the median. And notice there's a wide gap between these two. The reason why the mean is so much higher than the median is because we have a lot of very, very rich people who are pulling up that number way up. Like this is the Jeff Bezos effect. All right, so when you're just looking at an average, it's going to look like, wait, the average family, it would seem, makes over $100,000 a year. It's true, average income is over $100,000 a year, but I don't know very many families that make more than that. In fact, if you just take the median family, the middle number, you cut off the very poor and you cut out the very rich and you just look at the middle family. How much does that middle family make? It's about $80,000 a year. And that's for the household. So you've got, mom working, dad working, grandma working, some of the kids working, and all combined, they make $80,000 a year. Okay, so the difference between mean and median can be quite huge. And you should be careful about which one you use, because you could arrive at two very different conclusions depending on which statistic you use. Now let's switch over to Excel and see how we can calculate these two things so that we don't have to do it by hand. We'd much rather have a computer do it for us.